Okay, we're going to talk about on-farm culturing. This is an opportunity. It's really simple, but it's an opportunity to um, get ahead of things. And with getting ahead of things, you have an opportunity to save some money and help the cow out a little bit better. So, on-farm culturing, it takes about 24 hours to get readable plates. That can be a real benefit if you incorporate it into your treatment protocols. Gram positive versus gram negative, can identify the exact species. How do I proceed to try to help the animal cure itself? Do I provide treatment? Do I not provide treatment? How does that all work? A Y culture, it's a chance to cut mastitis coughs in half. You're going to reduce intramammary IMM antibiotic use. So you're going to stop treating quarters with no growth. You're going to stop treating gram negative infections. They tend to spontaneously cure. Um, so if you're using less antibiotics, you're going to use uh, less withhold time, less milk to be dumped, less chances of antibiotics entering the tank. You've got an opportunity to save money and hopefully treat the animals better. So you've got better treatment, less kind of flailing around in the dark. You're going to have a focused, targeted plan. The general thought about this: decrease time to get results. If your program can take advantage of that decreased time, there's uh, there's worth doing it. Up at the dairy, that's one less thing they want to do, so they send out twice a week samples to get tested. As you get thing about testing, at least general consensus from what you hear from people, yeah, we started out and we cured all our contagious. Once we get rid of our contagious, it all comes back gram negative most of the time. So there's really no benefit. It always comes back the same, Klebsiella or E. coli or something like that. We can pretty much guess what we got. It's one less thing I have to do. So that's why people tend to start it and stop. They're like, I'm coming up with the same results over with. But if you've got a somatic cell problem, don't know where to start, on farm culturing is a good way to get things headed in the right direction. So, what are you going to need? You're going to need to be able to take a good milk sample. So, you got those collection tubes, and then we're going to want to plate those samples, culture those samples. So, you're going to need the sterile applicators to take the milk out and put it on the plate or the tube, depending on how the media is set up. And then you're going to need an incubator to heat those up for 24 to 48 hours. We're going to do that sterile collection. We talked about that in the previous lecture. We're going to make sure we plate things out sterile. I demonstrated in a video how to do that. Pretty straightforward. We need to incubate for 24 to 48 hours, and then we need to read those plates. So we've got the Minnesota Culture Manual that's in your dairy references that help us identify what's on the plates. So this is if you want to make your own incubator, so take in some sort of cooler in one way, shape, or form. You're going to put a light into that cooler, and that's going to be your heat source. You don't need a lot. We're looking at 90 to 100 degrees. It doesn't have to be perfect. And then you've got a thermostat on that light that's going to turn that light on and off to provide the heat that you need in that um, cooler. It's probably just as simple if you're going to take this seriously to go get an egg incubator. They're pretty cheap, less than $100, maybe $50, especially this time of year when you got all the Easter egg things are done and the chicks are sold. There are opportunities to probably buy these pretty cheap. You can set them and more or less forget them. and I'm probably not that good with electronics. So we have one of these up at the dairy. We use it for this class, but since you're not here, it's going to be a little bit more difficult to get the use out of it that we're going to try. But the egg incubator, the chick incubators that you can set around 90 to 100 degrees are all you need. Doesn't have to be exact, just something that's going to heat things up, get things going. So to be successful on on-farm culturing, we're going to need a well-trained and interested person. You really got to want to do it. If you don't want to do it, it's probably not going to work out well. It's pretty easy to do. You can see here we're kind of leaning that thing over. We just put the swab in. We quickly swab the petri dish and we cover it back up, put it in the incubator. We need a proper mechanism to record the results. So Dairy Comp has spots for those, putting in your results, and then figuring out if we're going to do it, we're going to have to make it worthwhile, we're going to have to adjust treatment outcomes based on our results. So that flow chart I showed you in a previous lecture is one example. Working with your vet, say, okay, we got this, we're going to do that, we got this, we're going to do that. However that comes through, however that works in one way, shape, or form. So freezing samples, thawing them, we have to make sure we thaw them completely. Mix them up so we had a uniform whatever's in the thing there. Uh, Freezing and thawing helps disrupt some of the spores that might form for certain types of bacteria, and we might get a better plating, a better um, less less no results. We'll get something to grow where we don't freeze it. Sometimes we don't get growth. So plating, we got to take a good sample, which we've discussed previously. We transfer that thin coat like I demonstrated. You're supposed to heat them for 48 hours, but usually if you take a look at 24, you can get a pretty good idea where you're headed. I tend to look at them at 24 and then I go back and check them again at 48. If you guys were still here, we could do your own milk samples. We've done that in the past. You could easily do that, set yourself up to do samples. You contact Dairy One Ithaca, get you some tri plates, and you're on your way. Reading plates, we have the Minnesota Culture Manual in your dairy evaluation references, and we'll show you some pictures from that manual here to discuss how you'd identify various species of bacteria. So they have biplates or triplates. I usually get the triplates. So we've got two areas that'll grow gram positive. So this will be strep species only. And then you've got staph species only here, or gram positive, staph only growth over here. Strep grow in both of these. So if you've got growth in both of these, you're dealing with a strep. If you've only got growth over here, you have a staph. So there's a growth inhibitor that only allows strep to grow over here. And then your gram negatives over here on the McConkey. So you have these media that we talked about before in that flow chart. Now they're conveniently located in the tri-plates all in one place. So you can inoculate all the plates at once and figure out what you got by what grows where. So that's a zoom in. Again, we've got the three types of media that were mentioned before. Gram negatives grow here, strep and staph grow here, strep only grow there. So if we focus on the different types of media here, so we got the factor media, we've got a little dot here that they're growing, each in the center, and then they've got what's called a clearing area, hemolysis, where there's no color left around that colony. If that is the case, then you've got Staph aureus. if you've got those colonies growing on there in this corner over here, but no hemolysis, no clearing of the color, then you have general staph species. You're dealing with some sort of environmental, usually, organism. We move over to the strep only. So strep ag is going to give us the colony plus a clear ring, fairly good size around the outside. You've got strep dysaglacia. It's got a little bit of clearing, but they're a different color here. And then strep uberis is a black colony and a little bit of black staining in the auger. So 3 different strep species are going to react differently in this auger. So this is one that'll react well to penicillin. These are going to be more environmental. So looking at splitting out the two Streptococcus uberis and Enterococcus species, we split out the different colors here. You can see that we have that two-tone effect. We're dealing with the Enterococcus. If you're both black on black, you're going to have the Streptococcus. Lowering to the gram-negative, the McConkey auger. So if you've got kind of dry-looking zits here, you're going to have E. coli. If they're wet-looking, they're kind of glassy, shiny, you're going to have Klebsiella. And then you're kind of somewhere in between here, you've got the Enterobacter species. So all gram-negative. So we've got yellow colonies up here for Pseudomonas, yellow colonies, yellow around the colonies for Pseudomonas. Again, we've got that culture manual in there. You can leaf through that or flip through that on online or on your desktop there to see what flow charts are there and how you identify one species from another. Again, if you want to test your own milk, we have the facilities here to do that. I would have to buy some more plates, but if you're close by and want to do some stuff, we've got an incubator to get the job done. So I'll probably give you some plates, some pictures from plates past, and then you'll get your opportunity to figure out what's on those plates and we can compare notes. Normally we get a whole bunch of plates related to the samples brought in by the students. We pass them around, we figure out what is there, and everybody puts their votes in as to what they see on the various plates.